To conclude this report, let's read up what NOAA is imagining in terms of implementing the research strategy for CDR. So that's part 4 and the last part. Obviously, I'm being very brief with the report, but you get most of the salient points according to me. You can always go and read the report. So part 4, next steps, proposed development of CDR research and coordination at NOAA. NOAA is uniquely positioned to provide decision makers with the best available science related to the risk and benefits of climate intervention strategies. As a trusted agent and purveyor of the underlying science, data, tools, and information to help people understand and prepare for climate variability and change, NOAA has the internationally recognized expertise to collect the observations and conduct the research needed to understand the efficacy and implications of climate interventions. So hopefully this will be international effort, will be an international effort. I always tend to miss my articles. Gross negative emissions in gigaton CO2 per year, so that means that's over the emissions, how much more you're going to take out. So we are looking at ensemble projections of necessary carbon removal over time based on emissions targets that achieve 1.5 to 2 degrees C warming. Okay, it's old work, but still such estimates exist. And so you are expecting certain growth going from, let's say, 2022 or so, and there is a 6% annual growth happening here out to 2060, and then you are flattening, I suppose. There is a rapid increase, and then there is a slowdown, and then hopefully further slowdown, but somewhere you have to hit net zero. 2050 is considered the I think the time horizon to stay within these warming targets by 2100, with some reasonable probability like 67%. So you can see that the required gross negative emissions in gigaton CO2 per year have to go up quite a bit. We are in the range of 0 to as high as 16 17 gigaton CO2 per year. We looked in the previous podcast at building materials that can sequester maybe 16 gigaton CO2 per year. If that can materialize, in a optimistic view is that everybody is thinking about it. Everybody is doing this research, at least because it's a bit, expected to be a big market. So hopefully, just like the vaccines with COVID, we will succeed in this. So NOAA imagines 3 waves of carbon dioxide removal research. Wave 1, parallelized basic research. Wave 2, field trials and scaling. And wave 3, mature global monitoring. Okay, so even though this doesn't talk much about international coordination, obviously it will be, especially if large-scale climate engineering interventions begin to happen, like solar radiation management, which is being pushed very hard by some people as safe, even though there are no guarantees in life. So wave 1 examples: an interactive research strategy for assessing microalgal approach, so microalgal carbon removal. Early results from other projects have shown how difficult it is to measure and monitor carbon removal from macroalgal projects. Macroalgal, I said, I hope. Site selection and experimental designs are key. A strong knowledge of local background processes and of macroalgal modification processes, including growth and sinking, are required so that these signals can eventually be separated. Additionality is very critical. After that, you need to show duration and lack of leakage. Ideally, a regional or local model would be used to combine these factors to design successful experiments, but many model factors are currently unknown and can vary by location, species of macroalgae, and duration of the project. So if you start macroalgal cultivation farming as a way to do ocean CDR, how long do you have to keep going with it? How expensive will that be, and how effective, and so on, right? Biogeochemical models can help define scales at which these key factors can be tested in the laboratory, for example, rates of respiration. These results can then be applied in the models. Once biogeochemical and environmental impacts can be better projected, marine spatial planning tools can be developed to help site these projects, so implementation in a practical sense. Combined, these models and marine spatial planning tools can help cite small, controlled field programs that answer important research questions to make sure that these are actually workable, safe, and serve the purpose of additionality, duration, and leakage, right? Wave 2, you can, it's a link. So rapid technology development through public-private partnerships, sail drone USV as a case study and template. So obviously this many private players are in this already because it's expected to make a lot of money. Public-private partnerships and interagency agreements can be powerful collaborations to rapidly advance technologies by harnessing the strength of each type of organization, driving towards a shared vision of rapidly deploying ocean observing technology. Sail Drone Inc. and NOAA Research combined complementary skills in science and engineering to rapidly develop global classes of uncrewed surface vehicles, USV, uncrewed surface vehicles. For ocean research, NOAA Research has fundamental knowledge to design, operate, and improve global ocean observing systems for high impact phenomena such as ENSO, tsunami, and carbon flux. Sail Drone has the ability to leverage private capital and invest in the complex design and manufacturing of uncrewed vehicles, associated state-of-art software and electronics, and rapidly scale to meet the density of observations required to advance research and improve ocean forecasting. So there are some other details, but by emphasizing shared needs, complementary strengths, and a clear vision for a sustainable future observing system, this case study can serve as a blueprint for public and private partners to conduct field experiments and develop novel technology to accurately measure the fate of carbon. So monitoring, reporting, and verification are going to be key, because once this gets deployed, once these get deployed, and some claims are made about how much CO2 is being sequestered, there will be many candidates to pay for it as their offset. So reducing overall CO2 will be a big challenge, as well as making sure that people who claim additionality are in fact sequestering carbon, because many of the clean development mechanisms and offsets, for example, when you take a flight, you can pay a little fee to offset your carbon emission from the flight, but that money goes somewhere and you have no way of tracking who did what with that and whether they actually sequestered additional carbon to remove your flight emissions, right? So it's very tricky. This is the standard picture we look at in terms of sources and sinks of CO2, which we have discussed elsewhere. Basically, you have fossil fuels and land use change, and then uptake by the atmosphere, land sink, and the ocean. They don't always close the budget, but potential new CDR sink can be 0 to 9 gigatons CO2 per year, gigatons of CO2 per year in 2050, and 0 to 17 gigatons CO2 per year in 2100, just to stay carbon neutral. Even if you decarbonize the whole system, you will still have unintended or irreducible emissions, so this is needed either way. Okay, so essential wave 3 activities then: continued stakeholder engagement, clear public-private partnerships that enable monitoring of CDR industry, expansion of the global observing and modeling system to contribute to the verification and validation of CDR, and analysis of additionality, durability, and leakage. Development of best practices, documents, and methodologies. So when you say global observing and modeling system, NOAA typically works with local partners like India, Australia, European countries, and so on in each region. and satellite missions can also be shared between various countries from South America, Europe, India, Asia, and so on. So that has to continue, and hopefully by 2050 we have this thing figured out so that everybody is working together, recognizing that we are all in this together. Okay, what are the conclusions? While emissions reductions must occur, the scientific community agrees that in order to meet climate goals, negative emissions pathways must be employed. In this report, NOAA does not advocate for any specific CDR technique, but instead outlines existing CDR strategies and outlines how they overlap with NOAA's mission of science, service, and stewardship. Right? There are 4 main ways NOAA can leverage existing assets to verify and validate CDR research. First, NOAA's observing systems and Earth system models set a high standard for understanding and projecting CDR in the Earth system. NOAA will be able to help the global community set standards and adapt the observing system for proper monitoring, reporting, and verification of carbon drawdown that will be needed to understand CDR efficacy and impacts, value and ensure carbon assets, as well as understand the costs of the necessary carbon removal infrastructure that will need to be developed to achieve climate goals. So it talks about global community here, but you know that certain presidents may not believe in global anything. This requires making sure observing systems match the scales at which we need to monitor. And it's not a joke that the current president had some issues with NOAA in the past, hurricane predictions and so on. What he will do now with NOAA is not clear. So far he hasn't said anything, but he has obviously pulled out of Paris Agreement, so we'll have to watch and see what NOAA may even look like in a few years. Secondly, NOAA's ecosystem research, modeling and monitoring will help identify, understand and limit ecosystem risks from CDR installations. Decision makers should have transparent information about risks and co-benefits to determine whether CDR projects are effective, safe, sustainable and fair. NOAA can provide this information. So NOAA is charging hard to get this going. Third, NOAA service missions in restoration and spatial planning will help sustainably scale the CDR field. NOAA must ensure the efficacy of carbon removal projects, protecting living marine resources and supporting decision makers and communities. Finally, overall, NOAA can be a leader in responsible validation and verification of CDR strategies, which will require sustained multi-sector partnerships, also international partnerships. NOAA aims to promote knowledge transfer and outreach among federal agencies, the international community, public-private partnerships, non-profits, and community organizations. Okay, so it's a very US-centric report, but with global implications just in terms of technology, research and observation systems for monitoring and ensuring durability, additionality, leakage, etc. So obviously NOAA can invest, lead, and then global partners can join and benefit from working together, right? Because this is a mitigation problem and it's a global problem, and mitigation obviously has evolved with global leadership. Adaptation tends to be local, location specific, and there are finance issues, capacity building issues, knowledge transfer issues, etc. that are being dealt with in national adaptation plans and so on. But to the extent that mitigation is an activity that has easier global coordination, such CDR research by NOAA can be part of the global efforts on mitigation as well. Okay, so let's leave it here, and hopefully we can translate these to having similar entities in other countries like China and India, for example, to do CDR research in some particular place, and then implementation at global levels and coordination. Okay,